11.1 Systems of Linear Equations. Part 2 Solving Systems by Substitution and Elimination. Southwestern College, Professor Maria Olivas. Solving Systems of Linear Equations in Two Variables. Part 2. In this video, we will be doing the following objectives: solving systems of linear equations in two variables algebraically by substitution, solving systems of linear equations in two variables algebraically by elimination or linear combinations, and we're also going to solve applications involving systems of linear equations. All right, we are ready to move on to our next section here for this video. We're going to be solving systems using substitution. Because points of intersection are not always nice, we need another strategy for solving systems. Substitution is an algebraic method for solving systems of linear equations. To solve a system by substitution, 1. Take one of the equations and either solve for x or solve for y, whichever is easiest. 2. Substitute your x or y expression into the appropriate spot in the second equation. Solve that equation. 3. Substitute that solution back into the first equation to find your other coordinate. Write your solution as an ordered pair. 4. Check your solution. So let's go ahead and solve the following systems by substitution. Problem number 1. 4x minus 3y equals 9, and negative x plus 3y equals negative 3. Our first step would be to determine which one of the variables we want to solve for. The easiest one to solve for is this negative x in the second equation. Would be the easiest variable to isolate. So let's go ahead and choose the second equation, and we're going to solve for x. So the first thing we're going to do is we're going to subtract 3y from both sides of our equation. This will leave us with a negative x equals negative 3y minus 3. Now we can divide both sides by negative 1, which will give us x equals positive 3y plus 3. Now that we have solved for x, we can substitute this entire expression that x is equal to, which is the 3y plus 3, into the other equation. So the other equation was the 4x minus 3y equals 9. So I'm just going to go ahead and copy it right over here to the side. For x minus 3y equals 9. And in place of x, I am going to substitute the entire expression 3y plus 3. Now we are going to solve for y. We're going to distribute the 4 to the 3y plus 3. 4 times 3y will give me 12y. And then 4 times 3 will give me 12. So we will put plus 12. Bring down that minus 3y and then bring down that equals 9. All right, let's combine like terms. I can combine 12y with that minus 3y, and that'll give me 9y. I'll bring down that plus 12, and I'll bring down the equals 9. Now we can just go ahead and isolate the y by subtracting 12 to both sides. 9y is equal to 9 minus 12 is going to give me negative 3. We can divide both sides of the equation by 9 to isolate the y. And we have y is equal to negative 3/9 reduces to negative 1/3. Now that I have solved for y, I can take what y is equal to and substitute it back into this equation where it was solved for x, the one that said x equals 3y plus 3. Let me go ahead and write that equation again. So I'm going to write out x equals 3y plus 3. But instead of y, I am going to substitute y with the value that we just found for y. We're going to substitute that negative 1/3 for y. So I have circled where it says y equals negative 1/3 and drawn an arrow pointing where the y is in the equation x equals 3y plus 3. So next we're going to have x equals 3 times negative 1/3, and then we're going to add 3 to that. And then for our next line, I'm going to write down, and I've erased the circle and the arrow that I've drawn here so that that's not distracting us. Our next line is x equals negative 3/3 plus 3. X equals the negative 3/3 reduces to negative 1, and then plus 3. That's going to give us positive 2. I can write down my ordered pair as 2 comma negative 1/3. This is my solution to this system. Now our fourth step would be to check our solution, and you don't want to get lazy, right? We want to make sure we check our answers. So we're going to go ahead and take this and we're going to substitute this. All right, so I'm just going to move my work over here to the side so I have a little bit more space for me to be able to check my solution. All right, so let's go ahead and do our check right over here to the right. I have a little bit of space. So let's first check it in our first equation, the 4x minus 3y equals 9. I'm going to substitute 2 for x and negative 1/3 for y. So I'm going to end up with 4 times 2 is 8, and negative 3 times negative 1/3 is going to give me positive 3/3. We're trying to see if this equals 9. So this is 8 plus 1. Is that equal to 9? Yes, it is. 9 equals 9. This checks out. Next, we're going to check in the second equation. Then negative x plus 3y equals negative 3. So this will be negative 2 plus 3 times negative 1/3. And we're checking to see if this is equal to negative 3. Negative 2 minus 3/3. Is this equal to negative 3? This is negative 2 minus 1. And yes, this is equal to negative 3. It checks out. So yes, I am positive that this is the correct solution to this system. All right, problem number 2. Y equals negative 2x plus 10 and 3x plus 5y equals 8. Because this is already solved for y, we are just going to be able to directly substitute that negative 2x plus 10 into the y for the other equation. So this will be 3x plus 5 times the quantity, negative 2x plus 10 equals 8. Let's go ahead and distribute this 5 to the negative 2x into the 10. So this is going to give me 3x minus 10x plus 50 equals 8. 3x minus 10x is negative 7x, and then we have plus 50 equals 8. Now we can isolate the x. I'm going to subtract 50 from both sides of my equation. So this will give me negative 7x equals negative 42. We're going to divide both sides of the equation by a negative 7. So on the left-hand side, negative 7 divided by negative 7, they will divide out to just give me a 1. So we'll just have 1x. And negative 42 divided by negative 7 will give me a positive 6. So x is equal to 6. Now that we found what x is equal to, we can substitute this into that first equation that was already solved for y. So why don't we go ahead and copy this equation right over here to the right of it. So y equals negative 2x plus 10, but instead of x, I'm going to substitute 6. So now I'm going to circle where it says x equals 6. I've drawn an arrow pointing to the x in the equation y equals negative 2x plus 10. Our next line is going to say y equals negative 2 times 6 plus 10. So now we can simplify this and find what y is equal to. So for our next line, we're going to have y equals, if we multiply negative 2 times 6, we're going to end up with a negative 12. So that will say y equals negative 12 plus 10. Therefore, y equals negative 2. We will now rewrite our solution as an ordered pair. So this is going to be 6 comma negative 2. Let's go ahead and box that in. Now let's go ahead and check this to make sure that this is correct. Right, so we are ready to do the check. I am going to substitute 6 for x and negative 2 for y. And we're going to be checking this into both of our equations. So let's start off with the y equals negative 2x plus 10. Instead of y, we're going to substitute negative 2. So it'll be negative 2 equals negative 2 times 6 plus 10. So this says negative 2 equals negative 12 plus 10. Negative 2 equals negative 2, and that is a true statement. Therefore, yes, it checks out in our first equation. Second equation, 3x plus 5y equals 8. It'll be 3 times 6 plus 5 times negative 2 equals 8. We're trying to see if this is true. 3 times 6 is 18. And then 5 times negative 2 is a negative 10. So that'll be 18 minus 10. And that is equal to 8. So 8 equals 8. That is a true statement. Yes, it checks out. So it checks out into both of our equations, which means, yes, the ordered pair 6 comma negative 2 is a solution to our system. Excellent. Let's go ahead and move on to number 3. Problem number 3 says y equals 4x plus 3 and y equals 7x minus 6. Notice how they both are already solved for y. So what we only have to do is we just have to set these two expressions equal to each other. So I'm just going to go ahead and write 7x minus 6 equals 4x plus 3. And now we are going to solve for x. Let's get all of our x's to one side. So I'm going to subtract 4x from both sides of the equation. 7x minus 4x is 3x. And then we have bring down that minus 6 equals 3. Let's isolate the x. We're going to add 6 to both sides of our equation. This is going to give me 3x equals 9. Divide both sides of the equation by 3, and here we're going to have x equals 3. Now we're going to substitute this into either one of our two equations. Since they're both solved for y, either one is fine. I'm just going to go ahead and use the first one, the y equals 4x plus 3. And we're going to substitute 3 for x. So y equals 4 times 3 plus 3. Y equals 12 plus 3. So y is equal to 15. So this gives me our ordered pair, which is going to be 3 comma 15. Let's go ahead and box that in. And now let's check this solution and make sure it's correct. So for our check, I'm going to write down the word check right here, and I'm going to use the equation y equals 7x minus 6. And the reason I'm using this one is because I've already technically done the work with the y equals 4x plus 3 in the previous work that I just did. So if you're running short on time, you might want to just use the equation that you haven't used here. So our next line here would be 15 times 7 times 3 minus 6, and then we get 15 equals 21 minus 6, and 15 is equal to 15, and that checks out. So here, like I said, a technique you can use is if you're running short on time, you could just use the equation that you haven't used. So notice here I'm circling all the work that I did here with the y equals 4x plus 3. If you feel very confident with your work that you did there and you're running short on time, you might want to just use the other equation that you haven't used for your check. But if you have time, it's always a good idea to use both equations just to be a little bit safer with all your work. Okay? Number 4, we got 2x plus 3y equals 9 and x plus 2y equals 13 halves. Now the easiest one to solve for a variable would be the second one to solve for x. So we're going to isolate the x. We're going to subtract 2y from both sides on that second equation. We're going to have x is equal to a negative 2y plus 13 halves. Now that we have solved for x, we are going to substitute this entire expression into the other equation for x. So the other equation is that 2x plus 3y equals 9. But instead of x, we are going to substitute the expression negative 2y plus 13 halves. I am going to draw a cloud around the expression negative 2y plus 13 halves and an arrow pointing to the x in the equation 2x plus 3y equals 9. For the next line, we're going to have 2 times, open up a set of parentheses, negative 2y plus 13 halves, close the parentheses, plus 3y equals 9. Now we're going to erase the cloud and the arrow that I drew, and we're going to distribute the 2. 2 times negative 2y, that's going to give me a negative 4y. I'm just going to go ahead and write that over here to the side. And then 2 times 13 halves is going to give me 26 halves. And then plus 3y equals 9. We can combine like terms, so I can combine that negative 4y with that plus 3y and that'll give me a negative y. And I can simplify 26 halves to 13. We can subtract 13 from both sides of our equation. That'll leave me with negative y equals a negative 4. I can divide both sides of the equation by negative 1. And I will end up with y equals 4. Now that we have our value for y, I can go back and I can substitute that into either one of the two equations and solve for x. I'm going to take the equation that's already solved for x. So that's going to give me, that's the one that said x equals negative 2y plus 13 halves. So we will have x equals negative 2 times 4 plus 13 halves. This will give me x is equal to a negative 8 plus 13 halves. So let's go ahead and find a common denominator here. I'm going to write that negative 8 over a 1, multiply by 2 to the numerator and denominator, so I can have a least common denominator of 2. That'll give me negative 16 halves plus 13 halves. So x is going to be equal to a negative 3 halves. So my ordered pair will be negative 3 halves, comma, 4. So this ordered pair represents our solution to our system. So we're going to box that in, and that will be our final answer there. And I will leave the check for you guys. Number 5, x minus y equals negative 4, and negative 2x plus 2y equals negative 8. So the easiest variable to solve for here would be the x in our first equation. So we're going to add y to both sides of our equation. Then we're going to be left with x equals y minus 4. Now we're ready to substitute y minus 4 in place of x into our other equation, the negative 2x plus 2y equals negative 8. So every time I see an x in this equation, I'm going to substitute y minus 4. So that'll be negative 2 times the quantity y minus 4. Close the parentheses, plus 2y equals negative 8. Now we're going to distribute the negative 2 in front of our parentheses there. We will be left with a negative 2y plus 8 plus 2y equals negative 8. Now our negative 2y and our positive 2y are going to cancel out. They're going to add up to 0, and we'll be left with an 8 equals negative 8. This is a false statement. Since this is a false statement, then this means that there is no solution to this system. These two equations actually represent parallel lines that will never intersect. So for our final answer, we're going to write out the words no solution, or you can also write that as the empty set this way, as a 0 with a slash through it, or the empty set of braces. I'm going to box in all three, but you don't have to use all three of these. You could just use either one of these three to represent our answer. Okay, number 6. We have the system 3x plus y equals negative 1 and 6x plus 2y equals negative 2. The easiest variable to solve for here would be the y in the first equation, so we're going to subtract 3x from both sides of that equation to isolate the y. We will be left with a y equals negative 3x minus 1. Now we're ready to substitute this into our other equation. So we're going to substitute into that 6x plus 2y equals negative 2 equation. Every time I see a y in that equation, I am going to substitute the expression negative 3x minus 1 in place of it. So 6x plus 2 times the quantity negative 3x minus 1, close our parentheses, equals negative 2. Now let's distribute the 2 in front of the parentheses to the negative 3x into that minus 1. And we'll be left with 6x minus 6x minus 2 equals negative 2. Now the 6x and the negative 6x, or the minus 6x, is going to zero out when we add those up. And we'll be left with just negative 2 equals negative 2, which is a true statement. When you're left with a true statement, and all of your variables have canceled out, then this means that there are infinitely many solutions. So ultimately that means that the two original equations that were given to us are actually equivalent equations of each other, and they actually represent the exact same line. So in order to write down the solution set for this, we would either have to write our solution set as set builder notation as the set of all x comma y such that 3x plus y equals negative 1, and then close our set of braces. Or we could also write it as the set of all ordered pairs x comma y such that, and we could use the other equation, that 6x plus 2y equals negative 2, and then close our braces. Either one of those equations is fine because they actually both represent the same equation, so you could use either one. Another way that we could write this would be in our parametric form. We write it so it looks like an ordered pair. Open up a set of parentheses, write x comma And then here we would have to write y solved in terms of x. We would have this expression here, the negative 3x minus 1, which is equivalent to y, and it's in terms of x. And this is another way that we can write our solution. Either one of these is fine, so I'm going to box in all three, but once again, you don't have to write in all three. You could use either one of these to represent the solution set, and you would be fine. Now that we're done with that, we're ready to move on to our application problem. So before we start our application problem, we do need to discuss what is an equilibrium point. So let's begin with that. Equilibrium point. To find the equilibrium point, the quantity demanded must match the quantity produced. The equilibrium point will be where S of x equals d of x, where S of x represents the supply function and d of x represents the demand function. Supply and demand. Suppose that the price and the supply of the Shooting Star Bluetooth speaker are related by the equation y equals S of x equals 90 plus 30x, where y is the price in dollars at which the seller is willing to supply x thousand units. Also suppose that the price and the demand for the same speaker are related by the equation y equals d of x equals 200 minus 25x, where y is the price in dollars at which the consumer is willing to buy x thousand units. Find the equilibrium point for this speaker. I'm going to begin by circling the supply function. That is where it says y equals S of x equals 90 plus 30x. And I'm going to write down the words supply function underneath the problem. And right after that, I'm going to write the equation that represents the supply function. S of x equals 90 plus 30x. Now, if you recall from our definition of equilibrium point, it said that in order to find the equilibrium point, we need to find where S of x equals d of x. So I'm now going to write down the demand function. I'm going to write down the words demand function, and after that I'm going to write down the equation that represents the demand function, which is d of x equals 200 minus 25x. And I forgot to circle that equation where it was in the problem, so I'm going to go back up to the problem and I'm going to circle where you can find that equation. Now we're going to go ahead and set these two equations equal to each other. But first I'm going to underline, find the equilibrium point for this speaker, because that's what we need to do. And like I mentioned earlier, that is going to be where S of x equals d of x. So I am underlining in the definition of equilibrium point where it said equilibrium point will be where S of x equals d of x, and I've circled the part that says S of x equals d of x, and I'm also copying that down again as well here. So S of x equals d of x, but instead of S of x, I'm going to write down what S of x equals, which is 90 plus 30x. And then I'm going to set that equal to what d of x is equal to. So that's going to be equal to 200 minus 25x. And now we need to solve for x. So I need to get all of my x's to one side of the equal sign. So I'm going to go ahead and add 25x to both sides of my equal sign. So this is going to leave me with the following equation. I'm going to be left with 90 plus 55x equals 200. And that minus 25x and the plus 25x there, those will zero out. So I don't have to write down any x's on the right-hand side. Now I'm going to subtract 90 to both sides of the equal sign. So the 90s here on the left-hand side will zero out, and I'll just be left with 55x equals 110. Now I'm going to divide both sides by 55. 55 divided by 55, those are going to divide out and they're going to just give me a 1. So 1 times x is just x. And x is equal to 2, since 110 divided by 55 is equal to 2. And it is helpful to keep in mind here that this 2 actually represents 2,000 units, since the problem did say that x was represented in 1,000 units. I am going to draw a line here to separate the work. So now here on the right hand side, we are now going to find the value for y. So I'm going to write y equals, and I'm going to choose d of x. You could actually choose either one d of x or s of x. They'll both give you the same number. So I'm just going to choose d of x equals 200 minus 25x. Instead of the x, here I'm highlighting the x in yellow, and I'm also highlighting where it says x equals 2 in yellow. And I'm going to circle the 2, and I'm going to draw an arrow pointing to the x in the equation I just wrote down, because I'm going to substitute that value of 2 in for x. So I'm going to go ahead and write down y equals d of x. Actually, I'm just going to erase the d of x. We don't need to write down the d of x anymore. I'm just going to write down y equals 200 minus 25x. Instead of x, I'm going to write down a 2 since we're substituting 2. And we're going to have y equals 200 minus 50 and y equals 150. So now that we came up with the value for y, remember that y is represented in dollars because it represents the price. So now we're going to go ahead and just write this as an ordered pair. I'm going to open up a set of parentheses, and I'm going to write 2, 150, and then close my parentheses to represent this as an ordered pair because we were looking for a point. And I'm going to box that in. Now, if you are asked to explain further what these numbers represent, I'm going to go ahead and write down what each of these numbers represents. So here R2 represents the number of units, and it did say in the problem that it represents 1,000 units. So I'm going to draw a little arrow pointing up at the 2. And I'm going to go ahead and also look back in the problem where it said what x represented. And I'm going to circle that. So it said here x represented x 1,000 units. And there were 2 places in the problem that said it. So I'm going to circle both of those places. And underneath the 2 and underneath the arrow, I'm going to write down 1,000 units. So that just means that you're aware that that 2 actually represents 2,000 units. Now I'm going to draw an arrow up at the 150, our y value, and I'm going to look in the word problem here, and I'm circling where it said here, y is the price in dollars, and there's 2 places in the problem that it states that, and I'm going to circle both of those places so you can see that. And right underneath the 150, I'm going to write down price in dollars, just in case you are required to have to explain a little bit further about what these numbers represent. But because it was just asking for an equilibrium point here, we don't need to do that. We just need to find the point and box that in. And this does represent the point of intersection for these 2 lines.